Hello everyone, welcome back to Year 9 Mathematics. My name is Victor and today we're going to learn about distance between 2 points. Now, if I give you 2 points on a flat piece of paper, you can use a ruler to find the distance between them, that's for sure, but what if those dots are coordinates on a Cartesian plane? So this is like the x-axis, this is like the y-axis. Can you find those? Now today we'll learn how to calculate exact diagonal distance using a secret weapon, Pythagoras theorem. So here are 2 points here. A is 1, 2. B is at 4, 6. And we want the length of this diagonal line. I know it says 5 over there, but we need to learn how to plug and play into the formulas and whatever not. Just be patient for now. So we need to draw a right angle triangle because from these 2 points right here, let's assume that we don't have this triangle, of course, but we can easily count vertical and horizontal grid lines. So to draw a horizontal line straight from A, you just need to go from the right, and a vertical line straight from B. I've drawn them right here. They meet at the right angle. We have built a right angled triangle, as you can see right here. Now our mysterious diagonal line is going to be this right here. This is going to be a hypotenuse. You need to find these. So how long is the bottom horizontal line? So we just went from x equals 1 to x equals 4, as you can see right here. So this is a 1, this is 4, so we just went from there. The run is going to be 3. Now how long is the vertical rise? Because we just went from, this is 6 here, 6, and this is going to be 2, so 6 minus 2, and this is going to be 4, so the rise is 4. Now of course, if we use Pythagoras, we have a squared plus b squared equals c squared. So the two short sides squared and added together will give us the hypotenuse squared. And if we substitute our numbers, we'll have 3 squared equals 4 squared and equals 5 squared. Because 9 plus 16 is going to give us 25, and this is going to be 5 squared. And so we need to find c. C is going to be square root of 25, which is going to be 5. So c is going to be 5. So the distance between these 2 points is going to be exactly 5 units. Okay? Now, this is in terms of the formula itself. You use the Pythagoras theorem. It's pretty simple. You just minus these. What can I say? You can minus these coordinates together and add them all together, and you have this formula. And that should be it, really, for this hypotenuse. Now, of course, we do have some habits, of course. We want to draw a right angle triangle, and we also want to ask ourselves, like, does the magnitude really make sense visually? So let's look at the triangle. The horizontal is 3 and the vertical is 4. The diagonal must be the longest side, and because 5 is bigger than 4 and bigger than 3, but it shouldn't be massive. If you forgot to draw a square root at the end and you get something like 25, then you have forgotten to actually square root this, and 25 would actually look 5 times larger than this. So it shouldn't be too massive. So please recheck your answers. Okay. So we just really did all that. I did not do the drawing, of course, but if we were to do some kind of drawing, it would look something like this. You will find the point, you will try to find a right triangle like this, you find this point right here, find a right triangle, you calculate the calculate the run here, you calculate the rise, and then you will find the hypotenuse using Pythagoras. That's it. So whenever you need a diagonal distance, draw a right angle triangle and use Pythagoras, and always check if the magnitude does make sense visually. I'll see you next time. Thanks for watching.